Hello everyone, welcome to this video, DevSecOps and Continuous Assurance Tips and Tricks. You are probably heard about CICD or Continuous Integration and Continuous Deployment, but did you hear or know about Continuous Assurance? As we are moving fast with DevOps, we must not compromise security. DevSecOps or Rugged DevOps became very essential for DevOps. It introduces security as a shift-left mindset with a lot of practices. So it is not happening at the end anymore. Instead, it happens at very early in the beginning. And of course, it requires different techniques. The goals are still the same, but there are different ways to reach them. So besides continuous integration, continuous deployment, continuous delivery, continuous testing, we also have what we call continuous assurance, which has to be implemented within DevOps space. So in this video, I'm going to introduce what is the DevSecOps or Rugged DevOps. Then I will talk about the shift-left mindset. After that, I will talk about security and compliance within DevOps or continuous assurance. Then I will talk about what do we need to do to check for security. We need to understand what. Once we understand what, then we will go for how to check for security. After that, I will talk about OWASP or Open Web Application Security Project and what they are produced and how this can help us to improve our security practices. Then we will talk about continuous security validation within CICD pipeline. After that, I will talk about passive penetration test vs active penetration test and when we can use both of them in the pipeline. Then I will talk about infrastructure validation. So it is not we only validating the application, but we also validating the infrastructure. After that, I will talk about how we track the vulnerabilities. Once we found vulnerabilities, so how we track them so we can make sure that we don't forget them. Then we will talk about Secure DevOps Kit for Azure or AzSK, which a security kit provided by Microsoft that enable us to improve the security for our application and infrastructure. Then I will introduce Azure policy and how we can configure and assign policies for different Azure component. Then we will introduce about Azure Blueprints and how it works as a high-level container for role-based access and Azure policies as well as resource groups. Then we will talk about Azure Security Center. After that, we will talk about how we can automate the governance and compliance with different tools and techniques to make sure that we have the continuous assurance. Then we will talk about Azure Pipeline Security Extensions, different extensions existing on Azure DevOps Marketplace where we can use them to implement our security practices. Then I will give two examples of them. The first one is Sonar Cloud and the second is White Source Vault. Then I will give an example how we can control the deployment of our release based on the governance and compliance. If the release violates the policy, it will fail. But first, let me give you a quick introduction about myself. My name is Mohammed Radwan. I'm a developer technologies MVP and principal DevOps. So I have been doing software development for more than 15 years now. I worked with many projects, helped many customers, heavily participated in the community, worked in many countries for different projects. The more questions you ask, the more we all learn. So I will encourage you, don't hesitate. If you have a comment or question, please leave it in the comment of the video because this will raise the discussion which will bring more values for everyone. DevSecOps or Rugged DevOps. As we moving to DevOps, it means increasing the frequency of deployment in production. This business agility can't come at the expense of security. With continuous delivery, how do we ensure that our application is secure and stays secure? It's a big question. How can we find and fix security issues early in the process? This begins with practices commonly referred as a DevSecOps. So DevSecOps incorporates the security team and their ability into DevSec practices, making security responsibility of everyone on the team. If we look at the software development lifecycle and when usually the security happen, we can see that it is usually happen at the end or before the deployment. But within DevOps and as we are moving fast, we can't do that anymore. If we do that, it will delay our deployment from having fast cadence. We will not be able to have fast cadence. And in ability to keep our cadence fast, we need to have what we call shift left, which means that we bring these practices at the beginning, because we don't have time to do it later. If we don't do it in the beginning, either we will not be able to do it or we will not be able to move fast. So shift left is a key for DevOps if we want to move fast. And it is not only security that we need to shift left. We also shift left testing. The main idea here is we shift left all quality and security practices at the beginning to make sure we don't have anything at the end that may delay us from moving fast. Security and compliance within DevOps. In such a distributed environment and fast delivery cadence, companies need to adopt more micro-level security across application and infrastructure and have multiple lines of defense. DevOps is all about moving security and compliance scanning closer as early as possible. So DevOps can also help in improving the security because by moving fast, you become more secure because you are not leaving yourself in a standing vulnerable position. In order to have a successful and a trusted pipeline, we need to consider security testing as a part of our pipeline. Because compliance relies on automation, we will automate the pipeline and certify the pipelines, not each release that go through it. The goal of this approach is to switch the conversation with the security team from approving each release to approve the CICD process and having the ability to monitor and audit the process at any point in time. Security needs to shift from in to be evaluated at every step of the process. Securing application is a continuous process. This is why we call it continuous assurance. That includes secure application, infrastructure, design, architecture for continuous security validation and monitor for attacks. So what we need to do to check for security? What? First, we need to check our source code for vulnerabilities. Also, the open source libraries for vulnerabilities, because we may have good practices to prevent vulnerabilities in our source code, but the open source libraries that we consume, it may have some vulnerabilities. Also, we check the open source library for license because sometimes maybe the license is not allowed to be used in the ways that I might use. For example, some open source library license will not allow me to ship a commercial application based on their open source license. I must produce my application as an open source, otherwise I can't use their license. So it's very important as well to validate and verify the license. Also, the open source library version outdated because the library may be deprecated and it is not supported anymore. There is no maintainability for this library, and there is maybe, for example, a replacement for this library. And of course, by using non-maintainable libraries, these also bring risk because maybe I need support, I need help, and of course it will be outdated. And so it is very important also to scan for outdated libraries. Also check for infrastructure, of course, as a code to prevent. For example, I could check the infrastructure not has a public endpoint that not whitelisted in my environment, for example, and to check the infrastructure to prevent the environment, and also to check the actual infrastructure or the environment, because maybe I prevent that, but for any reason we created the environment, but someone has power permission and then he can change that. So I must also scan and check the existing or the actual infrastructure environment so I can understand the drift between my baseline and the actual environment. And it is not only measuring the drift, but also measuring and fixing that. Also to check for common vulnerabilities and exposure. There is CVE database where it has common vulnerability and exposure. I will show the website so you can use it to search for common vulnerabilities in their database, for example. So I need to make sure that I check all the common vulnerabilities and the exposure within my environment and application. As now we understand what, let's go for how. So how do we check for security? The first, by using static application security testing. These tools will scan the code, either the code under development, our source code, or the third-party libraries or the open source libraries that we are using. And of course, this will check for vulnerabilities, open source libraries license and vulnerabilities, outdated and deprecated license as well, and so on. The second is infrastructure analysis. And as we explained before, this will be scanning the infrastructure as code to prevent the vulnerabilities from creating the environment in the first place, and also scanning the actual environment to understand the drift from the baseline of the security and the current state, and also to understand and analyze what could be the fix for the existing drift in the environment. The third is using passive penetration testing, and which is dynamic analysis. In dynamic analysis, it is not just by scanning the code. We need to run the application and start testing it in a dynamic. This is a dynamic analysis. So in the passive penetration test, it scans the target site, but it doesn't try to manipulate the requested to expose more or additional vulnerabilities. This scan can run fast and are usually a good candidate for CI process that you want to complete in few minutes. This unlike the next test, which is active penetration test. It's still dynamic analysis, but the active penetration test can be used to simulate many techniques that hackers commonly use to attack website. This test can also be referred to dynamic or fuzzy test, because the tests are trying large number of different combinations to see how the site reacts to verify that it doesn't reveal any information. These tests can run for much longer time, and typically you don't want to cut this off at any particular time. These are better to be executed as a part of the nightly build because it will take longer time. This is example of CVE, and we can see here I can search for CVE by IDE of the common vulnerabilities ID to get more information about the common vulnerability. OWASP, or Open Web Application Security Project. So OWASP is a worldwide non-profit organization dedicated to help improve the quality of software, and they produce AzSK, which is a free penetration testing tool from beginners to professional. So they produce documents and tools. The most famous document they produce called the Top 10, which has top 10 vulnerabilities. Some of them is injection, never trust any user input, broken authentication, sensitive data exposure, broken access controls, and more. Also, they produce OWASP ZAB Docker image weekly that has all the common vulnerabilities updated. So this image will usually has all the vulnerability. This is why it is preferable to use the OWASP ZAB Docker image instead of installing ZAB on a local machine, because if I install it in the local machine, then I will not get the chance to update it. But using the Docker image, it means that I have all the latest update for the common vulnerabilities. Continuous security validation or continuous assurance should be added at each step from development through production to help ensure application is always secure. The goal of this approach, as we explained before, is to switch the conversation with the security team from approving each release to approve the CICD process. So if they trust the CICD, they can trust the output. So they should have the ability to monitor and audit the process at any point in time. Validation in the CICD begins before the developer commits the code. This by running static analysis code in the IDE of the development tools. And this will be the first line of defense to help prevent the vulnerabilities from being introduced in the source control. And to merge the code, a pull request is required to initiate the merge process and to ensure that all defined controls are being executed. The pull request should require a code review, which is the one manual but important check for identifying new issues being introduced into the code. Along with this manual check, commit should be linked to work items for auditing why the code change was made and require continuous integration and build the process to succeed before the push can be completed and the code can be merged. This continuous integration just as a pre-merge process. Once the merge is complete, then the continuous integration needs to execute it again. The primary difference between the two runs is that the pull request continuous integration process doesn't need to do any of the packaging and the staging that done in the CI build. So the CI build now should run static code analysis tests to ensure that the code is following all the rules. And of course, once it's complete, this will produce the packaging for the next step for deploying the package to the environment. Once the package is ready and the application is deployed to the first environment, it could be development or QA, then we should verify that there is no any security vulnerabilities in the running application. This can be accomplished executing automated penetration test against the application. And we will use penetration test for verifying for that. We explained before the difference between passive and active penetration test. And since we want to keep the CICD quickly as possible, so we will only run the passive test within the CICD because it could take few minutes, and we will run the full active penetration test as a nightly build. And for post penetration test, passive and active, we will use the OWASP ZAB container image. And as we explained before, we prefer to use the container image because it is updated better than installing WASP ZAB on a local installation on our environment. As an overview, the application CI/CD pipeline should run within a few minutes, so we don't want to include any long-running process. The nightly WASP ZAB can spider the website and run the full active scan to evaluate the most combination of possible vulnerabilities. Besides validating the application, we need to validate the infrastructure as well to check for any vulnerabilities. When we're using public cloud, we must validate that everything has been done securely. For example, to ensure non-whitelisted public endpoints or port have been detected. We can use Security Center or Azure policies for this validation, and if there is any violation, this will raise an infrastructure issues or bug. This runs as a part of the pipeline to provide immediate verification, but also needs to be executed each night to ensure that there aren't any resource publicly exposed that should not be. And again, this continuous assurance. We're validating infrastructure by first validating the infrastructure as code, this to prevent creating the environment according to our security rules. And also we validate the actual environment to measure and know the drift, then fix it. Because we could prevent the creation, but we want to make sure that after the creation of the environment, there is no change. And if there is any drift, we need to identify them first, then fix them. Once the scan completed, bugs are created automatically in the backlog. Resolved bugs will close if the vulnerability has been fixed and move back into in progress if the vulnerability still exists. In this way, vulnerabilities will be bugs that provide actionable work that can be tracked and measured. Secure DevOps Kit for Azure or AzSK. Azure DevOps Security Kit, it's a group of PowerShell commandlets and guidance for best practices. It scans your Azure resources or subscription by running PowerShell commands and provide a CSV with a full scan result with recommendation and also a fix script So we can run this script instead of manually fixing the drift. It doesn't have to be drift, I mean, with a recommendation. So I don't need to run them manually. It also has an Azure Pipeline extension, which has two tasks. One to scan the template, as we explained before, to prevent, and one to scan the environment for configuration drift analysis. We can use Azure DevOps Security Kit as a part of the CICD pipelines. So we can use to verify and validate the ARM template for continuous deployment. And also we can use it with the nightly build for configuration drift analysis. Here, how we can install the Azure DevOps Security Kit if you want to install it on our machine, a client machine. Once we install it, we can find all the commands here. This command, how we can run the scanning for Azure subscription. And this is the result as a CSV file, which has, as we can see, the status, verified, paused, manual, failed. It will include all the result. And here the generated script that I can run to fix all the recommended or the violation. When I look at Azure policies help for audit or enforce. So as we saw that many of the security concept is by preventing and also for auditing. Once I prevent, it doesn't mean that it's complete, because maybe I prevent of the creation, but I need to make sure that I can audit, and once I found the problem, I need to fix it. And this is exactly what we usually use with security. So for example, Azure policy, I can create a policy and assign a policy for different Azure component and resources. For example, creating a policy from Azure Portal or CLI REST API to prevent creation of VM with high cost or a specific region. So for example, I can create that this size of this machine can't be created in this region or this size at all for all regions. So I can create this policy denying and auditing the policy. Here we can see how we can create the policy and assign the policy. Azure Blueprints. So Azure Blueprints is combining the policies and the role-based access control and the ARM templates. So it is a container of containers in a very high level of layer, not only above the resource group, but can be also above the subscription. So it is a way to help the enterprise architect to use native Azure for their EA across the organization in a repeatable configuration manner. So they start defining the blueprint for their organization. And then once they have it, which has group of ARM templates, group of policy definitions, and a group of role-based access control, and then they start applying the Azure blueprints on different subscription, because usually for all enterprise companies they have many subscription, so this will be taking the layer on the top of all of that. So here the getting start for Azure Blueprint, where I can create blueprint definitions, assign blueprint, manage the assigned blueprint, and so on. Azure Security Center. Azure Security Center centralized security includes Azure policy, alerting, and monitoring. So instead of working with different security tools in different ways, it just grouped them in what it called Security Center. So it's centralized policy management. So you can ensure compliance with company and regulatory security requirements by centrally managed security policies across all hybrid cloud workloads. Continuous security assessment. It helps monitor the security of your machines, network, storage, data services, and applications, so to discover potential security issues. Actionable recommendation. It's offer prioritized and actionable security recommendation, so you can, for example, fix security vulnerabilities before they can be exploited by attackers. Advanced cloud defense. You can reduce the threats with just-in-time access to manage ports and whitelist to control application running on your VMs and so on. Prioritized alerts and incident. It gives you the ability to focus more on the critical threat first. And this is the overview page for Security Center in Azure Portal. I can combine these tools to automate governance and compliance to achieve the continuous assurance. So for example, I can use Azure DevOps Security Kit within the Azure pipeline so I can scan the army template and make sure that it does not violate our security rules, or I can use it in the nightly build pipeline to make scan the environment for analysis for configuration drift and fix them automatically. And also, instead of the pipeline, I can use the Azure automation with Azure Security Kit. Also, I can use the Azure pipeline to be rely on the Azure policy, so that pipeline will fail if the Azure policy doesn't satisfy. So there are many combinations are available. The main goal here is to automate the governance and compliance to make sure that we have a continuous assurance by preventing in the first place, then continuously checking and continuously fixing in an automation manner. There are many Azure pipeline security extensions which needed to cover different types of tasks in the security. For example, the open source library outdated and deprecated, the open source library vulnerabilities, our source code vulnerabilities, to run passive penetration test and active penetration test, and so on. For example, Sonar Cloud is a continuous code quality static analysis tool. It includes security as well as other code quality, like for example, maintainability. It has code smell and different quality codes analysis. Checkmarks is a static application security testing tool. White source for open source library and vulnerabilities and license. Black Duck for open source library as well, vulnerabilities and license. Bankskim, this is a binary static analysis tool that provides security and correctness result for Windows portable executable files. Let's take some example. So here, for example, the Sonar Cloud. Once we install the Sonar Cloud Azure Pipeline extension, we will have these tasks: prepare analysis on Sonar Cloud, run code analysis, publish analysis result. Once we publish the result, we can see here the vulnerabilities score, and then I can track the vulnerabilities back to the code or back to the source. Another example is white source Bolt. Once I install the extension, I will have a task where I can use it in the pipeline. And again, the white source Bolt will help for analysis the open source library for vulnerabilities and license. Here also another example how we integrate the release gate or the pipeline with Azure policies. So for example, I configure the deployment will be rely on Azure policy. And if the policy doesn't satisfy, then the deployment will fail, as we can see here. Another example of the tasks is Azure DevOps Deployment Kit 2 tasks, which is the ARM template checker and security verification for the existing environment or the running environment. At the end, I would like to thank you for watching the video. Please, if you have any question or comment, don't hesitate to ask or leave it in the video. Also, you can reach more information by clicking on the link for my blog that will appear at the end of the video, or any related video which will appear as well. Thank you.